Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
And welcome to another episode of Lost in Science, here recorded at the studios of 3CR. It's Beth, Chris and Stuart in the studio, with yet another fine week ahead of us, full of science, or behind us, whatever part of the week you find yourself in. And there's a lot happening in the world of science, which is good that we're here to talk about it. If science happens and no one talks about it, does it really happen? Stu.
Well, it's been a while since I talked about any elements, which I do from time to time. So I thought I would talk about nitrogen and what is nitrogen and why do we care what nitrogen is. It's actually pretty important in a lot of ways, especially biologically. But,
all of the ways.
In all the ways, yes. Politically, biologically, socially, and other ways too. Environmentally.
Okay, nitrogen. Chris.
Yes, well, I am talking about a story that was in the news back in February, which I wasn't going to talk about. I think, Stu, you asked me about it, something about the some quantum theory.
That they did a quantum calculation that meant that the universe wasn't expanding. Was that the one?
That is the one, that's right. Yeah, it was basically a theory that there was some quantum proof that there wasn't a singularity at the beginning of the universe. And I'm just going to look into that, see what it all meant, because it's kind of been sensationalized and badly reported, but
science sensationalized in the news. Who would have thought?
Yeah, like I said, it's kind of one of these things. Is it worth talking about? But look, let's just set the record straight, I guess. You know, since people are talking about it, people are asking about it, let's set the record straight.
Can you just say what we're setting the record straight again, Chris? Physics, but the universe.
No, it's this. It is this news report from back in February that said that there's this quantum proof that there wasn't the universe didn't have a beginning. That I'll give you the detail in a bit. But,
no, that's okay. I was trying to unravel the universe within your mind. It turns out that bats learn language, according to researchers in Israel. So we're going to look at some fruit bats learning language off their parents, and it turns out that cats also like music, but only when it's cat music.
Cool for cats.
On with the show.
Now, most people know that without air, people and animals will suffocate. Do we know this? We're pretty sure that we know this. And we also know that the reason for this is that our bodies require oxygen, which we get from breathing air. But
what about fish? You said without air.
Well, they do breathe oxygen, but they get it out of the water in a different way. Yeah. They are animals, that's true. Yeah. But most of the air in the atmosphere is not actually oxygen, which is kind of lucky in a way, because if the amount of oxygen in the atmosphere gets too high, a lot of things begin oxidizing, or in other words, they burst into flames. So if the oxygen level in the atmosphere is too high, you actually get an increase in forest fires and things like that, which is, an interesting part of the ecology of the world. But look, oxygen actually makes up around 20% of the atmosphere, and we need that to breathe. And the rest of it is nitrogen. So nitrogen is what I'm actually going to be talking about. So in the atmosphere, nitrogen is a colourless diatomic gas, meaning it has two nitrogen atoms stuck together, and that's how it always is when it's a gas up in the atmosphere. And nitrogen has an atomic number of 7, so it has 7 protons orbited by 7 electrons. But in this form, it's more or less inert and it doesn't really react with anything, which is why it's a good thing to be the filler in the atmosphere, because it's just sort of, taking up space and hanging out. And it's also the 7th most abundant element in the universe. So being that it's the 7th most abundant element in the universe, it comes as no surprise that it is a biologically important element.
Even though it's inert, like you said.
It's inert in the gaseous form,
right?
But there are other forms of nitrogen, and I'm going to get onto those. But as a biologically important element, it also has importance in other ways, especially for humans. And humans have found a number of ways to exploit the properties of nitrogen. It was first identified as a component of air in the 18th century by a number of different people in different places, all doing different experiments, which were quite similar in a lot of ways. But because a number of people sort of discovered it, they gave it their own names. So some of the names were, they called it noxious air, and someone called it burnt air. Someone called it phlogisticated air.
Which means burnt air, does it?
Yeah, harking back to the phlogiston theory of why things burnt in the atmosphere. And mephitic air, which also was referring to the fact that it wasn't very good to breathe. And most of these scientists discovered it. They identified its ability to suffocate small animals that they placed in glass jars full of nitrogen.
So that was after they separated the oxygen and the nitrogen.
Yeah, so they they burnt all the oxygen out of the air, and then they'd put little creatures inside and watch what happened, which is not a very nice way to spend your time. I hope they didn't enjoy it too much. So aside from suffocating animals, nitrogen is also very important. As I said, biologically, makes up a huge number of biological molecules that keep animals and other living things alive. So our favourite biological molecule, DNA, itself is formed with a nitrogenous building block. So a major part of the actual molecule itself is nitrogen. So no nitrogen, no DNA, no life. RNA has also got a large proportion of nitrogen, and amino acids, which are used to build proteins, also have big slabs of nitrogen.
So was nitrogen present in the atmosphere in early Earth, in the early days of evolution?
Yeah, it was there. It was there a long time, even before oxygen. There was not really that much oxygen around before about 2.5 billion years ago. There's hardly any, but nitrogen was present. It's, as I said, it's the 7th most abundant element in the universe, so that it was all over the place, really. Now, atmospheric nitrogen, which is the nitrogen in the air, is unavailable to living things. So how does it get into biological systems? So it's got to be converted into a usable form by a number of processes. So some of that actually happens just through electrical discharges in the atmosphere. So when there's lightning in the atmosphere, the electrical charge actually breaks up those little diatomic nitrogen gas particles, and some of that nitrogen turns into ammonium and some turns into nitrate, and then it starts raining and it gets washed down onto the ground where, bacteria and plants can absorb it and use it for their own purposes. Now, some soil bacteria have evolved mechanisms to draw nitrogen directly from the atmosphere, so they don't have to wait till it rains. They can actually, because there's, nitrogen gas is all the way down into the soil, and these little soil bacteria have figured out or developed a way of converting that gaseous nitrogen into biological or biologically useful forms of nitrogen. And some of those bacteria have even specialised further, and they have symbiotic relationships with plants. So the whole Fabaceae family, which is the peas and beans, have little bacteria that live in special nodules in their roots.
So your legumes.
Legumes, that's right.
This is the nitrogen-fixing bacteria.
They call it nitrogen-fixing. Right. So, clovers and things like that, which they grow in pasture, it's basically there. Well, it's nutritious, but it also helps improve the fertility of the soil. And also the Australian native species Allocasuarina, the genus Allocasuarina, have bacteria in their roots, different species of bacteria, which also fix nitrogen out of the atmosphere and make it biologically available to the plants. Once it's in the biosphere, the nitrogen is constantly cycled, and you will, if you ever read any biology, you'll read about the nitrogen cycle. So it's coming from the atmosphere into the soil, getting taken up by plants and animals, turned into all sorts of amazing things, and then some of it leaches out and breaks down, and some of it gets released back into the atmosphere again. So there's a constant cycle of nitrogen throughout the biosphere. So nitrogen fertilizer is important in agriculture because plants always need it as well. And before there was any artificial methods, which were developed in the 19th and 20th centuries, deposits of guano, which is just bird droppings, were actually politically important, and governments used to send people around the world looking for these piles of bird droppings so that they could harvest the nitrogen and take it home.
Okay, so it's not just phosphorus that you got out of those, it was nitrogen as well.
Nitrogen as well.
Okay.
And also, nitrogen became politically important because it's a component of saltpeter, which is used in gunpowder and explosives. So governments were looking for nitrogen in for other ways that had direct political importance beyond just feeding people. So there's also a number of industrial uses in neon lights. They use argon to make purpley sort of lights, but they can substitute nitrogen for argon because it's cheaper and easier to find. But one of the most fun uses I always thought with nitrogen is liquid nitrogen. When you make nitrogen into a liquid, it means you've got to cool it right down so it turns from a gas into a liquid. And to do that, you've got to cool it to below 195 degrees Celsius, minus 195 degrees Celsius. So that's pretty cold. So basically anything that comes in contact with it pretty much freezes instantly. And it's that...
Like Terminators.
Like Terminators when they're made out of liquid metal. But it's actually really useful because when you freeze something quickly, the ice crystals form very quickly and they're very, very small. So you can actually freeze living tissue and then revive it again after you unfreeze it because the ice crystals don't get very big. So they're very, very tiny ice crystals. So they use it for freezing, sperm samples and eggs and other human tissue samples and other tissue samples that they want to revive again later on. So it's very useful stuff. But, it's very difficult to imagine what life would be like without nitrogen because it's just everywhere. It's so important. Across Australia on the Community Radio Network, you're listening to Lost in Science.
All right, you are listening to Lost in Science. And look, as I said before, and I was very excited, thank you, Beth, talking about a story that hit the news in February. Now, this story, you might have seen the newspaper or on the radio or on the TV, said that some physicists had shown the universe didn't have a beginning, and this led a lot of people to believe that it had been proven that there was no Big Bang. Well, not really, I guess, is what we're trying to say. I didn't look at it at the time much because it was a complicated story with lots of quantum stuff in it, and I'm a bit lazy. And
you're on holidays.
Well, yeah, and I thought that look, if it turns out to be a big deal, then other physicists will talk about it, and it'll become a lot of discussion. And then maybe I'll read the paper. But since you asked me about it, Stu, whatever happened to that, I think was.
I was curious because I read it and I thought, wow, that's potentially earth-shattering, but then I thought the same thing as you. If it was really, really important, then it would probably get more airtime than it did in the end.
So I think there's something to be said there about over-sensationally overhyping science results. But look, let's just talk about the actual science there. I think the first thing to say is that this paper, which is the paper is called Cosmology from Quantum Potential. It was published in the journal Physics Letters B by two researchers called Ahmad Farag Ali and Soria Das. It did not disprove the Big Bang. Let's just get out there right off the bat. What it is actually talking about was essentially what came before the Big Bang. So the simplest way of looking at things, I suppose, in our understanding of the way gravity and Einstein's theory of relativity works, is that there was a singularity and a point of zero space and time at the very beginning, and that exploded into the Big Bang.
Into everything that exists now.
Now, there's some problems with singularities. A lot of people don't like this idea of a singularity. A lot of people are trying to figure out how we can get around doing that because the laws of physics break down at this point. So this paper is suggesting a means of using quantum theory to get around there being this singularity. It's not questioning the whole kind of explosion that came after, which is the Big Bang. There is a lot of good evidence for the Big Bang. The two main pieces of evidence are that when we look out at the universe, we see everything moving away from everything else. Mm-hmm. So we use the Doppler effect, which I think we've talked about before on the show. That's where things coming towards you have a higher frequency than when they're going away. Beth, would you like to impersonate the Doppler effect?
Sure.
That's exactly it. So the frequency is higher when it's coming towards you. It's low when it's going away. When we look at things in the universe, we see their light towards the lower frequencies, which is the red end of the spectrum. We call it a red shift because the frequencies are getting lower as a result of them moving away from us. So the fact that you see everything moving away from you means that everything was once a lot closer together. We also see radiation coming from every point in space, and this is called the cosmic microwave background radiation. It's this heat that fills the entire universe, and it's basically the leftover heat from an explosion. So the fact that we see this kind of heat from an explosion, we see everything moving apart, implies that there was a really big explosion early on. It's very hard to explain these two bits of evidence without there being a Big Bang. So the Big Bang theory is generally quite well accepted, and not many people question it. There are, of course, some people who try and think of ways around it, but yeah, the basic Big Bang theory is pretty straightforward.
So we don't have to develop a new world order. That theory still stands. That
theory still stands, but we are questioning this singularity at the beginning. So essentially, what these guys did in their paper was they looked at so they tried to introduce some sort of quantum mechanics to see what would happen if we can find a way to get around the singularity by putting quantum theory into it. Quantum theory doesn't normally play nicely with Einstein's relativity, so you've got to find tricky ways to do it. And what they assumed was they made some assumptions about what dark matter is, and dark matter, of course, being this mysterious matter that's all throughout the universe. There's 10 times as much of it as there is normal matter. We just don't know what it is. They made some assumptions about that. They made some calculations, and they found that that it would prevent there ever being a singularity at the beginning. Now, it is quite an interesting result. They said from this that it would imply that the universe was always around, just very, very, very small, and then one day decided to explode with the Big Bang for no reason that no one can quite explain. But basically, there's no actual zero beginning. There's basically a very tiny universe that existed for forever until it decided to explode.
So it's always been there.
Yeah.
So, but this is all this is calculation, right? This is just mathematical calculation.
Yeah, this is a theory.
There's no way you can actually test this in any sort of empirical way.
Well, the thing that everyone says with these kind of things is once we have a good understanding of how quantum physics and relativity fit together, then we will know. We'll be able to make these calculations a lot better, and we will know a lot more definite. These guys have made some assumptions. They've actually used a particular variety of quantum mechanics that not everyone agrees with. So I don't know whether their results hold up if you use the standard theories that most people use. But it's an interesting test, I guess, of trying to do this sort of calculations and what happens out of it, what it would mean of our understanding of how the universe works. So yeah, look, it doesn't disprove the Big Bang, and it's not definitely right that this is what happened, but it's an interesting possibility that they have done some calculations, said this is what could have happened.
Making the assumptions that they made.
That they've made, yeah.
And using an unpopular version.
Yeah, okay, so it's sounding not too good from all that, but when they say, then you get a headline saying the universe has always been around forever and there was no beginning, that sounds big. I mean, that's big news. So, it just depends how you sell your science, I guess.
All right, so it turns out that fruit bats, and specifically Egyptian fruit bats, learn language from their parents, or they learn their sounds from their parents and from their society. So researchers from the University of Tel Aviv in Israel have found this out by listening to a fruit bat pup over its lifetime with and without its parents. So it's interesting because language evolution in humans is really not very well understood. So this is a mammal demonstrating language acquisition and learning. So it's interesting for itself and for what it means for understanding human language. So the Egyptian fruit bat, it's a long-lived social mammal, and it can live to about 25 years when it's in captivity. In the wild, they congregate in colonies of hundreds to thousands of individuals, so it's very social.
So similar to the ones we get here.
Yeah, exactly. And their social interactions are extremely vocal, just like the ones we get here. I've heard the fruit bats being
flying foxes.
They're very noisy.
Yeah, they are. And so their vocalizations are composed of sequences of short calls, but they have a really, really rich acoustic repertoire. So there's lots of them. And so
they have got really big ears, so they must be able to hear lots of things.
True. And so what they did is they continuously recorded the bats from birth to adulthood and found that when they're in a colony, pups acquired the adult repertoire, but when they were isolated, which sounds a bit cruel, they exhibited underdeveloped vocalization, so they didn't learn. So we're going to have a listen to some of these bats and see what they sound like.
What's that we listened to there?
That was just the sound of the cacophony of the bat colony itself.
So there was a whole colony.
Yeah, that was a lot.
From a distance.
Yeah. It was recorded in a cave in central Israel.
Right.
So that was like, that's thousands of bats talking to each other. But I've got another one that's a little bit more comprehensible. So it's an individual bat. So this is kind of honing in on one of those bats to see what they sound like. That was it.
Okay.
How about, let's do it again.
Listen to it again.
Doesn't mean anything to me, but then I'm not Egyptian.
Or not a fruit bat. So there, it's chatting away. So apparently those noises are learnt from their parents.
So I guess this is something that we often have wondered with animals. Like you have, say, for instance, dogs barking. You think, do, say, French dogs speak the same barks as other dogs? Do they have different languages? And it's just kind of saying that there is a language within a colony.
But that's a mammal, so I'm not really sure how that translates across the animal kingdom. But bats are related to us.
Yeah.
So we can speak language. But dogs, I don't know.
They're mammals.
I don't know. But what I do know, actually, is about cats.
Okay.
And cats apparently like to listen to music if it's specifically composed for them, whereas they don't really like to listen to human music.
So they only listen to, like, Cat Power, Cat Stevens,
yeah.
soundtrack from Cats.
So researchers, there's been a collaboration between a composer and a psychology professor from America, from the University of Wisconsin-Madison. They have a lot more funding for science over there, so they can do things like this. And they have shown that cats kind of ignore our music, and I think they were playing them classical music, so not pop, not cat power. But they're very highly responsive to music if it's been written for them.
Where did they find music written for them?
Well, that's when the composer came into play. So the composer wrote music to suit the cat's sensory system. So, for example, cats vocalise 1 octave higher than people. So the pitch was in that, higher than 1 octave higher. And they also created the music so it had a tempo that was appealing to cats. So it was based on the tempo of purring, and the other one was on the sucking sound made during nursing. So if that's not going to get a cat happy, I don't know what is. And the experiment was that they watched 47 cats individually, and after a period of silence, they turned the music on and they watched the cat. So purring, walking towards the speaker, rubbing against it were judged to be positive responses, while hissing, arcing the back and erecting the fur were negative responses. So do you want to hear the cat music?
I can't wait to hear the cat music.
All right, settle in. All right, that was for all the cats out there trying to get to sleep.
I do want to try that on my cat now and see what reaction it has.
So what does this tell us?
Well, so that was the music composed for cats, and that's courtesy of Charles Snowden from the University of Wisconsin-Madison and David T., who is the composer from the University of Maryland. They also made a music for a monkey, so you can look out for that as well. It tells you that animals are listening to their own sounds. I don't know.
They listen to things that we don't. I mean, I've noticed too that cats just sitting around will hear things and react to them that I can't hear at all too.
Imaginary things sometimes.
Well, I don't even think they're imaginary, but I think they hear noises more strongly and at different frequencies than we do, and they, we think they're reacting to something imaginary, but it's probably a mouse in the wall or in the roof or something, and so why would they like our music?
I think there's already enough people buying strange things for their pets. Now we're going to see people buying music for their pets, and
as long as they're happy and they're not getting upset by it.
Okay.
People can spend their money however they wish.
I want to hear music for fruit bats.
Yeah.
That could be a rocking
Well, I
tune.
wonder, maybe they could rehabilitate those isolated fruit bats by playing them specially composed music for them.
Bat music.
To the Bat Cave.
And you've been listening to Lost in Science. That's another show. It's time to wrap up. We've covered quite a bit. Nitrogen, omnipresent and...
Hugely important. You could not live without it, literally.
Literally. And Chris...
Universe, you couldn't live without that either.
No, lucky that was here.
Yeah.
Otherwise the nitrogen would have no place to be.
That's right. And music.
Cats and bats.
Yeah.
They have ears, they will use them, and they learn language if you're a bat. And maybe cats do too, but we don't know. But we know that cats like music when it's designed for their tastes.
They're already tyrants enough. Do we really need to encourage them?
No. Lost in Science is recorded at the studios of 3CR and supported by the Community Broadcast Foundation. And they air it across Australia on the Community Broadcast Network. And thanks to them. And you can tune in again next week and listen to us, or you can listen to our podcast. We've got a new podcasting system.
Oh, yeah. Check out our podcast on 3cr.org.au/lostinscience.
And you can send us an email, lostinsci@gmail.com, or check us out on social media. Or just tune in again next week as Beth, Chris and Stuart get
Lost in Science!
You've been listening to a 3CR podcast produced in the studios of independent community radio station 3CR in Melbourne, Australia. For more information, go to allthews.3cr.org.au.